When Tom invited me to submit something for this forum, what I immediately thought of was my primary background, my training has been in probabilistic information retrieval or ranked document retrieval. And I've noticed over decades in that field that there's been a lot more attention paid to representing the content of documents or document collections rather than representing the user's information need. So at an abstract way of thinking about the document retrieval problem, you can, and there are some instances of document retrieval where maybe this is overly elaborate way to think about it, but in other cases, you would want to consider that someone who writes the document is representing intellectual content that's being put in document form. Someone with an information need has sort of in their mental state, there's something missing that represents a need that they're going to try to satisfy by retrieving a set of documents, which then by reading they will find by sort of going from the document to the intellectual content the author was trying to represent, they will come up with something that will hopefully fill their information need. And then as I started to think about a particular use case, I sort of took things in a little bit different direction, which will become more apparent on the next slide. But the anomalous states of knowledge itself was a concept that was originally developed by Nicholas Belkin, Robert Oddie. Helen Brooks also worked with them on some of their earlier papers. And they took this perspective. They developed an information retrieval system or research prototype that was based on these ideas and involved iterative information retrieval where you could try to do retrieval based on these ideas. So as I sort of have gone over already, that information retrieval can be thought of as a matching operation and between the content in the document and the sort of gap in the mental state of the user. And so I'll skip over that. Let's see, go back up here for a minute. Okay, I was sort of thrown off because what I see is different from what you see on the screen. So I was, yes. So actually I have what is the outline. That's what I thought I was going to be talking about on the next slide. So, right. So I guess I'll go back to the outline now. So I've talked about the anomalous states of knowledge and information retrieval. So I was just getting to the point of talking about disinformation. So when a lot of information retrieval, or probably text analytics, is based on the tacit assumption that the content you can take at its face value. And I think I remember statistics about how high the error rate is in, say, published text. But aside from that kind of error rate, there can also be misinformation or disinformation. And when I came to Dartmouth College in 2001, I was involved with a project, which I'll talk about a little bit more here, called the Semantic Hacking Project, where we were looking at trying to detect disinformation on the web. We were funded by the Justice Department. I'll go into more of that in detail. But then something else I'll talk about a little bit as part of this use case is a research product from Wellesley College called Twitter Trails, which is designed to give an end user an interface to try to see what's going on with tweets and determine sort of fake news or non-fake news tweets and sort of look at how an initial sort of seminal tweet took place and then how that propagated. And what you can tell with a fairly surface level analysis, it's not real in-depth sentiment analysis or NLP, but gets into that extent or looks at the patterns of how more real versus fake if you will, tweets propagate. Now, I guess back to the next slide again. And I guess to say a little bit more about my background, why I sort of came to have this interest in the sort of discrepancy between the focus on the document and the collection versus the user's information need is I've tried to work in information retrieval throughout my career and haven't had too much luck with that. So I worked for West Publishing Company in the legal domain with the Westlaw Legal Information Retrieval System. I went there because they were the first large-scale commercial vendor to release a ranked document retrieval system in the early 90s, just as the World Wide Web was coming out and you started to have web search engines. But interestingly, something like 99% of legal information retrieval users, and this was also true of our main competitor, LexisNexis, because they had the choice, they chose to do search in the traditional Boolean operator way instead of using ranked document retrieval. So most of my work ended up being in the area of machine learning text categorization rather than document retrieval. So anyway, this has sort of led to my continuing interest, especially as now we have web search engines and there's a lot of focus on the content of the web, but not in that many applications is there an equal attention given to the user's information need, I would argue at least. So, and this is the page which I think I pretty much already covered. And so then a little bit more about, I have to make sure I'm looking at the right slide, anomalous states of knowledge. So as I mentioned, this work was done in the late 70s, early 80s by Belkin, Brooks, and Adi. So a user doesn't necessarily understand what their information need is. And granted, this isn't always the case, but if this is the case, then it can be especially difficult to translate that information need into a query, whether it's in a traditional Boolean system or a web search or whatever. So there's this anomalous gap in the user's information state. So their idea and their retrieval system prototype was to develop an iterative interface which allowed the user to go back and forth with the system to help clarify what their information need actually was. And then, so I left what was then Thompson West Group, or part of West Publishing Company was acquired by the Thompson Corporation in the mid-90s. This was long before Reuters, but I left in 2001 and went to Dartmouth College, where I'm some years later still there. And but in this early stage, I was working at the Institute for Security Technology Studies. And the focus of this institute was computer security. And the particular project which I inherited was the detection of misinformation or disinformation on the web. And so in terms of computer security, we took as our starting point a paper by Martin Libicki from the National Defense University at the time. He now works at RAND. And he wrote a paper in 1994, The Mesh and the Net, Speculations on Armed Conflict in an Age of Free Silicon, where he developed a taxonomy related to attacks on computer systems of physical, syntactic, and semantic attacks. So a physical attack would be just literally destroying some hardware, like a computer or whatever. A syntactic attack would cover pretty much everything covered by the field of computer security, worms, viruses, distributed and denial of service attacks, and so on. Whereas a semantic attack, or as we later started calling them in some papers, cognitive attacks, was thinking of the computer system as a communication system where perhaps in the attack, the attacker isn't necessarily violating any protocols of the computer system. So it's not something that could be detected in traditional computer security, but rather they're just trying to deceive the end user who is reading this. So it could just be a blog, or in another case, like there was an example of someone who had worked for a news service, press service, and they had left, but they still had access to their account, so they logged in and just sent out a fake news release to manipulate a company's stock. But, so there and even, phishing, like phishing, which wasn't a term that had been invented yet, but that was the kind of thing we talked about. So, of course, detecting deception on the web is a pretty broad area that's been around for long before computers, so you could call it perception management, or Dorothy Denning wrote a book on information warfare, information operations that aim to affect the perceptions of others in order to influence their emotions, reasoning, decisions, and ultimately actions. Or you can look at this also on a continuum. So at one end of the spectrum, you have things like propaganda or psychological operations and warfare. On an arguably more beneficial end of the spectrum, you have advertising or education. One of the areas that the first time I gave a talk on this, somebody said, but why aren't you just talking about social engineering? And not necessarily, because what we were talking about necessarily involved the computer. So in social engineering, someone might call a company and talk to an employee and learn something that then they can use to break into their system. So, but that wouldn't be what we were calling semantic hacking, because that just involved communication over the phone. And so anyway, I just had a little graphic here as well showing this sort of Venn diagram of social engineering versus cognitive or semantic hacking, and various terms, and the physical, syntactic, and semantic attacks. Then the sort of definition we eventually came up with was a networked information system attack that relies on changing human users' perceptions and corresponding behaviors in order to be successful. I pretty much went over this. And so now, in our earlier work, we were just developing countermeasures to try to detect this misinformation or disinformation. And we came across a set of data that had been originally developed at the University of Massachusetts Amherst. There was a project called Anomalous, where some more details on a slide coming up, but it's basically financial news where they had the ticker symbol and they also had the actual stock prices during the same time period. And they were looking at this data to try to see whether their language modeling approach to information retrieval could predict future stock prices, whereas we got the idea of trying to see if we could, detect any disinformation that might be in the news using the same data set. So the end user wants to find a possibly misinforming news item. The user wants to act quickly and make a big profit if this is true, but on the other hand doesn't want to fall victim to a pump and dump scheme. So a query would be automatically generated by our prototype, submitted to the Google News API, which would collect a collection of related ranked news items. And so, and how this relates to the user's need and whatnot, as opposed to just modeling the collection, is that this approach to document retrieval is based on the idea of relevance feedback. So you're retrieving documents to the user is providing relevance judgment. Say you give the user 20 documents, the user says these 3 are relevant, these 17 are not relevant. And then the system uses this information to re-rank documents and do another iteration of retrieval. Some of the early web search engines had this feature, but more like this. You have a highly relevant document, but users never tended to use that, so search engines tend not to have that anymore. And it was pointed out to me once that this is a reason that Google's PageRank algorithm works, because they're representing a document not only by the text of that document, but when that document links to another document, they're using, or another document ranks to the document you're trying to rank, they're using the anchor text from where the link came in the second document to add to the representation of the first document. So in a sense, you are getting a human relevance judgment from the user's mental state to help rank documents, not just the collection or the document itself. So we developed this news verifier prototype, and this was just very hastily towards the end of our 2 years of funding, so we didn't go too far with it. But I also, as a sort of thought experiment, considered possible other countermeasures. So in our work, we also said you might have a more mathematical way of trying to detect manipulation of a company's stock price, just looking at sort of idiosyncratic movements of the stock price, and which we called information trajectory modeling. And I thought it might be useful to try to compare these two systems, but we never did. And it was pointed out to me also that the stocks whose prices tend to get manipulated by fake news, as we would say now, tend to be low cap stocks that in any case would always move pretty erratically anyway. So, and this is just a little more background on the Anomalous project at UMass Amherst. So this is part of Victor Lavrenko's PhD work. And some more sort of theoretical background that this had to do with this activity monitoring sort of approach that Fawcett and Provost developed. Okay, so bringing it up to the present day, Twitter trails. Professor Panagiotis Metaxas at Wellesley read about our early work on the semantic hacking project, and for many years was funded by the NSF to do work, some of which included developing this Twitter trails product. And the National Science Foundation has a grant that you can get to try to commercialize your NSF-funded research. So Takas and I, Panagiotis, and I currently have a grant to try to commercialize this product. And so it can be used to detect reliable and less reliable tweets, investigate the origin and propagation characteristics of rumor, visualize burst activity, and so on and so on. And then another aspect of this I wanted to talk about was reflexive control theory, first developed in the 1960s in the Soviet Union. And government researchers here speculate that Russia, say in the 2016 US election, for example, is still using this theory to manipulate users' voting behavior, for example. So, again, this is an attempt to understand the user's information need or the user's information state, because in reflexive control theory, the practitioner of this sort of deception, to have effective deception is based on a very thorough understanding of the culture of the person you're trying to deceive. And so this seems to fit well with the Twitter trails and anomalous state of knowledge sort of perspective. And so, in conclusion, information retrieval can be more effective if more effort is put into modeling the user's information need as opposed to just analyzing the text. So you don't just do a web query and return, the top 10 million documents in response to the 1 or 2 word user query. And, clickstream mining, we're not sure necessarily how web search engines are using that data, but potentially they could build fairly elaborate models of the user's mental state. Whether they do or not is proprietary, I suppose. And also, we really, in some settings at least, can't just take information at face value, but have to consider a possible adversary's intent to manipulate this user's information need. Okay. And then I have references here, the Belkin and Adi work. This is our work with Henri Gianni and George Sabenko and myself. Fawcett and Prost. And Lefebvre is the chief person who worked on reflexive control theory. He came to the U.S. in the 1980s and is still active. Martin Libicki's original paper, which was the basis for our project. And a recent paper by Takis Metaxas and one of his colleagues.